Hey everyone, welcome to the Physics of Bikes, which are a perfect platform to demonstrate Newton's laws and some other physics. But first, a brief history on bikes.
Bikes have been helping people get from point A to point B since as early as the 1810s. The design back then also had two wheels, but was missing the chain and pedal system that allowed you to move the bike. By the 1870s, high wheel bikes were created, and they did include pedals, but they only helped turn the front wheel. Around the 1880s to 90s, the bikes we see nowadays started to come to life. The bikes had relatively the same size wheels and a pedal and chain system, but this time the chain rotated only the back wheel. As time went on, bikes began to become popular thanks to their transportation benefits. Fast forward some more, by the 1920s, bikes became known as children's toys, but actual children's bikes weren't created until the 1940s. Weird, right? Bikes were still a very good and effective mode of transportation even after World War II. In fact, North America was still using cruiser bikes because of their comfort and design. Sleeker and lighter road bikes became more popular after the 1950s after being imported from England. As the decades go on, people began to learn how energy efficient and fun it is to ride bikes. At the same time, bikes became outfitted with more gears and a sleeker design. Today, we have multiple types of bikes, like BMX, mountain, and recumbent bicycles. Bikes sure have come a long way since the 1800s. Any sentient being may know that an object in motion stays in motion. In a perfect world, Poe could stop pedaling and coast for all eternity. Goodbye, Poe. But this is reality. And here, we have something called friction. Friction is the force an object exerts against another object in contact with it. In this case, there is friction here, 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 and here. This causes Poe to slow from approximately 3.88 meters per second squared to 0 without any rider input. This brings us to the second part of Newton's first law. An object in motion stays in motion unless acted upon by another force, in this case, friction. Bicycles can control how much friction they experience. This is done through a device called brakes. The brakes press inward towards the wheel rim and cause an increase in friction on the wheel. This is enough to slow the bike from 3.8 meters per second in less than a second, as opposed to 28 seconds without brakes. Thanks, friction! In order to ride a bike, a rider must exert force on the pedals. This is the related equation. Together, Poe and his bike weigh 170 pounds, so it takes him 28 seconds to stop from a velocity of 3.8 meters per second. However, Toby needs a lift, so he hops on and increases the weight from 170 pounds to 270 pounds approximately, because Toby is 16 years old and just reached triple digits. Because of this increased mass, the deacceleration increases from negative 0.11 meters per second squared with just Poe to negative 0.17 meters per second squared with Poe and Toby. For every action, there is an equal and opposite reaction. Not only is this a Full Metal Alchemist reference, it's also Newton's third law. Now, lean over and push the person next to you. You will find that the person pushed back.
But Tim, what if they were nice and didn't push back?
If they didn't push back, they would be breaking the laws of physics. Even if the person didn't actually hit back, they are still applying force to your hand. This force is the equal and opposite reaction of you pushing the person. This happens all the time with bikes. While riding or resting, bikes are exerting force on the ground. However, because the bike has not fallen through the pavement, the ground is applying the exact same force upward towards the bike, keeping it in place. Enough about Newton. Let's rewind to a few thousand years to, you guessed it, ancient Greece. Said the great mathematician Archimedes, "Give me a lever and a place to stand, and I will move the earth." Said Poe, "Give me your bike and a pedal to stand on, and I will move Toby." Archimedes never moved the earth, but Poe seems to have gotten the hang of biking. This is because the pedal is just the circular version of Archimedes' lever. Notice that for every turn the pedal makes, the wheel spins 7 times. This is called mechanical advantage, and it is what allows bikes to reach higher speeds than a human on foot, even though both are exerting roughly the same amount of energy. Why? Because the two gears on a bike are of different sizes. The gear the pedal is turning is 7 times the circumference of the gear chain to it. Human legs are more adept to applying great force than reaching greater speeds. This means that, though the pedals become harder to turn, someone can push them and the wheel will spin faster than the pedal.
In addition to these forces on the bike, there is centripetal acceleration. This is the force inward when a wheel rotates. A good example of this is the wheels on the bike. On this particular bike, the wheels have a diameter of 27 inches. This means their circumference is 85 inches, which is also equal to 2.15 meters. In the clip, Poe goes 11.5 meters, which means the wheels did 5.4 revolutions over the 3-second period that he rode. So they go 1.78 rotations per second. We found one revolution to be 2.15 meters, so it goes a velocity of 3.83 meters per second. This velocity squared divided by the radius, which we found was 0.343 meters, gives us the centripetal acceleration of the wheel to be 42.8 meters per second squared. That about wraps up all the forces on the bike. Thank you guys for watching and have a great day.